to more community-oriented stuff, we'll go back to the technical stuff. My name is Roxana. I'm working for Xenit Solutions, which is a Belgian partner of Alfresco, and together with Axel, we'll give a presentation about sharding. This work started in 2016, and back then Alfresco didn't have had only one sharding method by ACLs, which was suited maybe in the case of a rich permission system or sites, but we didn't have sites. We had large archives, and we had a particular use case to have most of the queries targeted to a particular client. So we implemented our own sharding strategy by property with targeted queries, and we made a sort of Solr lab to experiment on it. We work a lot with Docker at Xenit, so we chose sharding by property. A few words about it. So on the tracker side, implementation is almost identical to the current existing implementation in Alfresco 5.2. Basically, the distribution of documents into shard is done based on a hashing function involving the value of the sharded property we want to shard on. So nowadays, this exists in Alfresco 5.2. On the Alfresco side, we have a custom feature, let's say. So the idea is to bypass the distributed handler of Solr and to target the shard, the query directly to one specific shard by using the same hashing function as on the Solr side. We chose for the Solr lab to work with Docker and Docker Compose because, of course, it's easy to start, to replicate, to monitor, to resume. And we invested a lot of time in building images and sort of orchestrate them via Docker Compose files. So I will shortly give you an example to see of what kind of things we can change via Docker Compose files, via environment variables. So we can change not only Alfresco global properties and Solr core properties, but also Java ops and schema things and server.xml properties. So we have an init script which replaces the values with the values given by the environment variables. Of course, we didn't know how it's going to behave, so we defined the sort of dimensions to work on, like the size of the repository, number of shards. We introduced artificial ACLs to have a better distribution of documents into shards in the ACL sharding method. And we measured the number of things, like most important and obvious, the response times of the queries. We started at Amazon. We quickly realized it's going to get out of control there in terms of costs. So we moved to Hetzner. We used a dedicated server, very powerful, as you could see there. Okay. Loading the documents. We used a custom program. We didn't upload content, but it reached a speed of about 1 million documents in 45 minutes. So we managed to load 100 million documents in a bit more than 3 days. It scaled well. So this is unlike the scaling exercise from Alfresco, not using any ingestion server and stuff like that. Of course, we ran into a number of problems. The most obvious and undocumented from Alfresco is the running out of inodes on the Solr partition, and then you have to start from scratch.
So I joined Xenit late in the stage of this laboratory, basically to just run the tests and check the results and analyze performance issues. Here you just see some excerpts of our results that we got. We did a lot of tests across various dimensions. So basically the conclusions we could draw from those tests and analyzing the different bottlenecks within the system is that if the search is slow, it's usually not Solr that is slow, it's a system around it. For example, Alfresco database bulk loading of the search results into the caches of Alfresco, or the sizing of the caches might be too low to actually cover the use case. The secondary culprit in the terms of performance typically can also be found in the ACL checking on the repository side after the results are returned. Even if you specify you don't want permissions to be checked, they are still checked in specific conditions, unless you run it as a system user or as an admin user and have something returned from Solr as well. In general, judging the sharding by property and targeted query execution, we found that it's consistently faster than Fresco default by about 20%, even up to 100%. We're currently in the progress of doing further tests on the 100 million test case, so we just loaded it and ran the first couple of tests and have to expand the test case as well. And we are planning to do the same test on a customer hardware using Oracle database server.